Hey, and welcome back to Gaming for Tokens. In this episode, we're going to pick up right where we left off in the last video, where we were talking about code and behavior states and things like that. We just got done talking about investigate, and we're going to jump right into what pursue means. And in the last video, I talked about this little differentiation between attack and pursue, and why that was a wonky thing. The state for attack makes sense because you're going to be attacking while you're in that state, which is why it's defined like this. But the behavior state of pursue, or the function called pursue, makes a lot more sense because we're going to be pursuing while we attack. So I kind of made the decision partway through to not call it one or the other and just to kind of mix and match. And probably a bad thing, but it works for me, and it makes sense in my head, but it probably wouldn't make sense to other people, and that's not a good thing. Typically speaking, you basically want to program for other people. You don't want to program for yourself, because if you program for other people, then anybody can pick up your code and go, and you can also do that. It's weird. When I say program for other people, typically speaking, it's your interpretation of what other people need. So you end up making it for yourself and other people. It's bizarre. But anyway, jumping into what pursue is. There it is. So what we want to do is, if our target is not null, so if we have a target, we want to draw a line to that target. This is a debug thing. We want to draw a red line to that target specifically. This is just a thing so I can see that they're detecting it and who they're detecting pretty easily. It's not like a necessary thing, but it's useful to do this, is my point. Then we're going to check the distance. We're going to check the distance between us and them. And we're going to say, hey, are they within our attack distance? Like basically our attack range. And if they are, if they are, then we're going to look directly at them, which is kind of terrifying. When you see it happen in Engine, when the AI is actually like wandering around, it's kind of funny because they get like within a certain distance of each other and they just stop and they stare at each other, which I liked a lot actually, so I kept it in. But basically what this is, it's to prevent this thing that I saw happening, which was really interesting. The AI would kind of like, they would get towards each other and they would start spinning around each other really, really fast, and they would be attacking each other while they did that. And I didn't really like that because they were always trying to look at the other person, but the other person was moving, so they'd end up moving to accommodate that, and then they would end up like just spinning around each other really fast and always be within the attack distance so they could attack. It was bizarre. Anyway, so I just made it, no, you're just going to snap directly towards that other person, and we're going to be done with that. And then we're going to do the attack cooldown nonsense. So basically what this says is, I'm doing this in a weird way. So time.time is the amount of time that has happened since the last scene change, I think. Or it's either the last scene change or when the game was loaded. So I think it's one of those two. Either way, I'm subtracting the last attack time because, as you see right here, I set the last attack time to the time that we attacked. So effectively what I'm doing is I'm setting a timestamp for when we attacked last, and I'm comparing to when we're trying to attack now to the last time that we attacked to determine if the difference is bigger than our cooldown. I could have used an actual timer here where I declared a float value and I increment that float value by time.delta time like I do everywhere else, like right here for example. I could have done this nonsense. But this is technically the better way to do it. It's kind of weird, but it is. I just wanted to show you guys two different ways of approaching the same problem, basically. So if one makes sense to you, great. If the other doesn't, then great. I would suggest using this one if you can wrap your head around it. It's just, what time is it? Great. What time did we attack last? Okay, is the difference between those greater than our attack cooldown? Cool. Then we're going to actually attack again. And when we attack, we're going to record when we attacked. So if you think about it like I can attack once per minute, and I last attacked at 3:01, and it is 3:02, that means I can attack. But because it's 3:01 and it's like 40 seconds into it, I have to wait another 20 seconds. That's essentially what I'm doing here. So I set an int value damage for attack info.getDamage. Now, I think I went over this in the last, well, not the last video, but the video before it, about why everything is an int value for health. And it's because it's easier to determine when something dies. If you're shaving off like fractions of a 1, it's kind of annoying. But if you do straight int values, then you always know that like your minimum damage is going to be 1, or well 0 technically, but like the minimum amount of damage that you can deal and still have it deal damage is 1. So it's easier to message that to the player instead of showing them a crazy float value that's like 0.157321. Like, you can just say, no, you did a damage if you need to. And I think that int value health systems are much better than float value health systems. I don't know. It's just my opinion on things, I guess. It doesn't really matter. Anyway, attack info.get damage. So what does that do? I believe our attack info is at the top up here somewhere. Attack info. Get damage just returns a random range. I chose to do this in a class because I guess just because I did. I wanted all of this to be self-contained in a single class for organization's sake, and if I need to change anything with the attack, I can do that here. Say that I also had like a type of damage that I would deal, then I could set up an enumerator here and return an enumerator as well, or like a damage class. I could write a whole damage class that has like who's dealing the damage and what type of damage is it and how much damage is it and yada yada yada, like what it was the weapon that they used or whatever. I can do all that within this class up here and keep it all pretty well contained and organized, instead of all just spewing it out down here in Pursue, which was it's a bad place to do that. So anyway, that's that. And then a debug line, because I like my debug lines and everyone should. And I set that time like I was talking about, the timestamp thing, and then I send message damage to my current target. I think I've talked, I'm 90% sure that I talked about send message in another video, but basically target.send message, and then I'm feeding the damage, the int value that I got, and I'll show you what that looks like. What damage is right here. So it receives the int value, and then it clamps the health. It sets our health value, our current health value, to a clamped variant on it. So the reason why I'm doing this is because I didn't want negative health. If I ever do a health bar, I want to be able to get my my non-negative health. I always want the minimum that a health can ever be to be 0. So I say that current health equals mathf.clamp, and if you don't know what clamp does, it basically says give me a value, well here, give me a value and give me a minimum and a maximum, and then I'll set that value to be within those constraints. So if I feed it the value of current health minus the damage, so so say that our current health is 50, and I subtract 10 from that, then our current health is going to be 40. That's what this is saying. So 40 clamped between 0 and whatever our base health is. Say our base health is 100 and 0. So if we had 25 health and I subtracted 30 from that, then it would come out as 0, because 0 is, or -5 is less than 0, but it clamps it at 0, if that makes sense. Anyway, and then I check to make sure that we're above 0 health, and if we're not, then I remove myself from my enemies and allies lists. I kind of talked about that in the last video, about how the removal and additions of enemies and allies works. So this is basically me saying I'm dead now, so I'm going to tell all my enemies and allies that I'm dead. And then I'm going to set the game object to inactive. And the reason why I'm doing that is because I thought it could be interesting to not destroy a game object, because that's effectively what this does. It just turns it off. And that's kind of what I'm saying here. We could use destroy, but I didn't want to. Technically, this is more efficient, I hear. I don't know how true that is, but I believe it's probably very true. Set active effectively does the exact same thing as destroy, except you can reactivate it later if you want, which is kind of handy. Anyway, that's damage. Effectively, this is death, and that is how that works. So, pursue. So anyway, ascending damage to something, and then if they are not within our attack distance, so again, this is like in this big if statement for if we can reach them. If we can't reach them, though, then we're going to discern what direction they're going in, and we're going to move in that direction. That's all this does. This stupidly long attack position line is terrible. Discern the direction from us to them, or rather to them from us. Yeah. And then find our attack position based off of our position plus the direction times the distance and blah 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 blah. Vector 3 distance, the difference in the distance between us and them minus the attack distance. Yeah, so I'm doing it this way for a reason. It has to do with that whole orbiting around each other thing, because they would get up close and they would just like circle around each other, like I was saying, because they were trying to get to the other person's position as well. That was what drove the majority of the swirling around each other. That was what made them move, is my point. And then the looking was what made them swirl. So like instead of just grinding against each other, they like spun into oblivion. It was insane. So this is effectively saying move in the direction of the target and stop moving when you're close enough to attack them, is essentially what this is saying. So find the direction to them and then go in that direction a distance equal to the distance between you and them minus the attack distance, if that makes sense at all. I hope that does. If not, here it is in all of its Cody glory. Yeah. So that's the attack position, then I set that as the destination. And if we don't have a target at any point in time when we're pursuing, I immediately switch to the investigate state. That caused me a lot of problems early on, but I fixed all of them, it seems like. Basically, the gist is, if we're pursuing someone and they disappear, because of the check LOS thing, which we're going to go into next, if they disappear, then we want to go investigate where we last saw them. Okay, so that is pursue. If you've been paying attention, you know that the next thing is the check LOS, a check target LOS function. The worst function in this whole thing. Not the worst, just the hardest to describe, and the longest, and the most complicated. Okay, so this is the point of check LOS, check target LOS, is to check if we have line of sight on any of our targets. So we go through our enemies list and we are going to see if we can see them. And if we can see them, then we're going to change our state based on how we can see them and the state that we're in. Detection on AI is one of the hardest things to get right. I'm not saying that I did it right. I am going to say that I did it to some capacity. And it's not very... What I'm going to show you isn't very advanced, but I mean, it's already this complicated, and it's not very advanced. So the gist is, we need to make a vision cone. And when I made the vision cone the first time, I did some nonsense. That's what's commented out and stuff. It was a mess. What I was trying to do is I was trying to actually make a cone, right? I was trying to have a, like, using geometry, have a what am I? Yeah, I wasn't doing what I'm doing now, which is just how far forward should I go and how far wide should the cone be? How far wide? Wow. How wide should the cone be and how far out should it go? I wasn't doing that before. I was doing some crazy stupid thing where I had like a vision angle and I was trying to like, if your vision angle was 60 degrees, how far out would you go based on the circumference of a circle around you and stuff like that. It was just nonsense. It was overly complicated. And I mean, it was a cool system, but effectively the only thing it awarded me was being able to put degrees in as a float instead of a distance in. And I'd much rather, as a designer, be able to tweak a distance and a width than I would a degree and kind of eyeball it. So at the head of the last video, I talked about that I changed some variables from part 3. From part 3, I changed some of the variables between 3 and 4 being the last video, I hope. And what I changed was the cone width and the cone distance. Vision distance and cone width. Before I had a vision angle, and now I have a cone width. Basically, that's the difference. So the cone goes out a certain distance and then is that wide from corner to corner. So, oh man, I wish I could illustrate this a little better. Oh, maybe I can. Perfect. Okay, cool. So these guys here, which this may look a little different last time too. Basically, I go out a certain amount, out to the vision distance, and then I come from here to here in a rounded fashion. So technically, this is, I think this might be a lie, the debug viz, because I think that it'll come out to that distance and then it'll come down in a radius like that. So I think it'll only probably come out to like there or so. I could be wrong on that. It's been a while since I looked at this code. But basically the gist is I set a width and I set a distance. So I effectively create a T. And that is much more handy than, I don't know, however wide that is whatever. And then I have a distance that is maybe accurate. So anyway, that's what I changed. Going back down to LOS. Going back down to LOS. There it is. Cool. So what I'm doing is I'm setting offset variables, or offset vectors. And the offset vectors are the corners, the ends of those green lines that we saw. And then I draw lines to them down here. So basically, the way that I'm doing it is I'm saying, hey, whatever the transform forward is, go out that far on the vision distance, and then go to the right however wide our cone is, divided by 2. The reason why I'm dividing it by 2 is because it's the full width of our cone, not half the width of our cone, that we're defining as a variable up top. So I need to cut that in half to only get half of it. So in other words, what I'm doing here, let me bring this back up again. What I'm doing is I'm saying go out so far and then go right half the width of the cone, and then go out and then go left half the width of the cone. So again, go out a certain distance, our vision distance, and then go right half the width of our cone, and then go out a certain distance, and then go left half the distance of our cone. And that gives us our 2 points on the corners of our vision cone. And it's more of a two-dimensional cone than anything, I think. I could be wrong on that. I don't remember. Anyway, that's all just to get the debug info. Which is really funny. I mean, all of that to get the debug info. I know. Anyway, so the next thing we're going to do is we're going to create a Ambient AI list of all of the ones that we can see. And it's going to be 0 big so far. And we're going to create a vector 3 for our forward corner. What that means is basically I think this specific corner is our forward right corner. So this is the reason why we're doing it is because we want to get the angle to that, so that way we can compare when an AI is within that angle. This is also something that I had changed in when I changed those variables around, because this before I think was like 4 or 5 lines of code and it wasn't working because it was too complicated, because I was doing angles and converting float values to radians and back, and oh, it was terrible. It was the worst. But this way what I'm doing is I'm just saying, cool, where is that forward right corner, and then what is the angle to that corner? Great, if our AI are outside of that angle from us, then we don't see them. Done. So to get an angle, you vector 3 at an angle, you feed it a 2 directions. So the forward direction of us, so think about it like you have a pole of some kind and you're holding it out from your chest. That's the forward vector, right? And then you're holding out your right arm at a right angle, and we want to know, well, I said at a right angle, but you're holding your right arm out perpendicular to that. Again, perpendicular implies right angle. Whatever, you get what I'm trying to say. And we're going to normalize the vectors from our to our right forward right corner, blah, from us. That's what this is. I always get confused on that. I hate that. Ugh. Anyway, so again, our angle is going to be from our forward vector to the forward corner position. But again, it takes two directions, so we have to discern the direction from us to that corner to get the angle. Hopefully that makes sense. This is the line. But yeah. And then we're going to do a for loop for everything in our enemies list. And we're going to add those to the can see array, as we've done in a couple things. As we've done a couple ways. So we're going to say the angle to our target is this. Much the same that we did the angle here. We're just going to get the angle from our forward position to the position there. Now the interesting thing is the vector theta angle always returns the smallest angle it can. So what we need to do is discern whether or not, and we're going to do that down here, this if statement here, because it always returns the smallest angle it can, we can't just say if you're greater than a certain angle, because sometimes it'll return a negative angle to the left. Well, no, it's always positive. Huh. So it's always going to return, oh, weird. Maybe it will be negative. I don't know. There was something that I did with it. Anyway, we'll get there when we get there, but just know that vector3.angle always returns the smallest angle it can. So the smaller of the two. It'll never return something greater than it'll never return 180 or more, is the point. It'll always return the smaller of the two. Great. So the distance is the distance from us to them, so from our position to the enemy position. And then I'm doing some debug stuff here just to get the angles and stuff like that so I could read it when I was fixing things when they broke. And then we're going to say if the angle to the target is less than or equal to the max angle. Yeah, okay, cool, yeah. So max angle, or the vector theta angle, never returns a negative value. I don't know why I couldn't remember if that was the case or not, but yeah, this right here says that. So if our angle is less than the max angle, which we set up here, we set our max angle here, and we set our angle to target here. If our angle is less than that, then and our distance is less than or equal to our vision distance, so we can see them, and they're within our cone of vision, and distance is less than our auto detect distance, or distance is less than our auto detect. So auto detect distance is something special that I rigged up to essentially simulate sound. There is no sound. The AI don't make noise. Oh, cars. But they should behave as though they do, and that's kind of my mentality. This is also my designery, I don't know, my designery mentality sneaking in. But basically the idea being that if an AI gets within a certain distance of another AI, they will automatically detect each other because they'll hear each other, is the idea. So even if they're like backing into each other, they'll get like, I think it's 5 units or something, or like 3 units. They get within 3 units of each other and they'll immediately turn around and start killing each other. That's what that does. So that's why there's an OR statement, or an OR check there. Anyway, if that's the case, if you detect the AI, then you're going to run a line cast to them. And we're going to see if we can actually see them. Because they can be in our cone of vision or within that certain distance and on the other side of a wall. So we need to check to see if there is a wall there. So that's what we're doing here. We're saying, hey, if your line of sight check doesn't hit anything, then great, perfect. Draw a line to them and add them. Wait. Yeah, then add them to the can see list. Alright, so that's the first part of that done. We've gathered all of the AI that we can see. That's the important thing. Now what we're going to do, with that can see list, I believe we just go through and we find the nearest one. That's all we do. So we're just saying that, like, first off, if there is anybody in the can see list, and if not, then we don't have any targets and whatever, go into investigate mode. Wait. If perception info... Oh, yeah, okay, never mind. Okay, so if there's someone in the can see list, then do this. If there isn't, then what we want to do is check to see if we have a target. If we do have a target, then we want to say that target doesn't exist anymore. We don't have one anymore. And then we want to go in the investigate state. I forgot about that. This is basically saying that, hey, I see someone. Now I don't see them. I should go look at where they were. It's essentially the same thing as the pursue state check that I had going on, but for just like seeing someone and then not seeing them. It's not redundant because you could be in like a flee state. I don't know. I don't know if a flee state would actually let you do that. Whatever. Anyway, this is basically just like, hey, I saw somebody, now I don't. I'm gonna go investigate. That's all it is. So maybe you're not in the pursue state and you need to investigate something. You can. That's all this does. But if there is someone in the can see list, then we're going to store the slot that they're in here. Which, by the way, I default this to 0 instead of -1 because we're going to find someone, right? Because there's someone in that list, and we should default to the first one in that list if we can. And then we're gonna the nearest dist is going to be the distance that they are from us, the closest one. And I'm going to start with the vision distance as a default because I know that they're at least within the vision distance of us, because otherwise we wouldn't have been able to see them. They wouldn't have been added to that list. So then I'm going to go for loop through the things that we can see, and I'm going to say, hey, is the distance from me to you less than or equal to the nearest dist? Great. Then that's going to be our new nearest dist, is the distance from me to you, and you're going to be my closest target. And then in the end, after that for loop is done, I'm going to say, hey, you're my current target, and my last known position is your position. And this happens every frame. All of that does. This whole like check LOS function happens every frame. So every single frame I will be recording where who my closest target is and what their last position was. And that's important for being able to chase them. It's important for being able to know where they were for investigations, and it's important for just overall perception. It's kind of like they're aware of their surroundings and they kind of have a memory. That's kind of what this is simulating. So if our current state is not attack and our current state isn't flee, then we want to turn into we want to set it to attack. So this is saying that, like, what is this? Okay, so we have a target who is within our range, and yeah, we have a target that is within our range. We want to go chase him down and beat him up, is basically what this is saying. But we only want to do that if we're not fleeing and we're not already chasing someone down and beating them up. If that makes sense at all. So yeah, that's that. And that is the entire check LOS thing. I hope that makes some kind of sense. It's a meaty function, to say the least. In the descriptions for this video, and I think the last videos, I will hopefully have uploaded all of this and attached it to that video, I hope. Well, I don't know. Anyway, so you could actually dissect this for yourself and tell me what I did wrong. But I believe that's everything. I think I did it. I think I got through it. Yeah, alright, cool. Well, yeah, just for one last hurrah, let's, hey, look. They do stuff. They wander around. It's amazing. It's almost like they're alive. But they're not. They're absolutely not. It's nothing like that because they're AI, and they're actually kind of dumb AI. But anyway, hopefully this was helpful. Hopefully, yeah, hopefully you don't have too many questions, but if you do, by all means, ask them in the comments. Hit me up on Twitter. Dissect my code. Probably, some of you are going to say my terribly written code. That's fine. I mean, it probably is. Again, I'm a designer, not a programmer. But I enjoy this stuff. I hope you guys do too. And I am sorry about the delay in videos. I'm hoping to get this video and the last video up on the same day, if not at least a day apart. Just comes down to editing and such. So, yeah. Yeah, that's everything, I think. Thanks for watching, and bye-bye.